I am Dr. P.R. Vani, Assistant Professor in Zoology, Dr. V.S. Krishna, Government Degree College, Visakhapatnam. In this video, I am going to explain about Mendel and his laws in 3 videos. The first video will be about Mendel. In the second video, I am going to explain about Mendel's first law, that is, law of segregation. And in the third video, we are going to understand Mendel's second law, that is, law of independent assortment. Now, what are the learning objectives from this video? We are going to learn about the origin of branch of genetics, the importance of scientific discovery, the knowledge on method of experimentation, how heredity and variations take place, and whether a particular law is applicable universally or not. Now, there are some questions. Can you guess the answers for this? If not, you are going to get the answers for all these questions by the end of these videos. The first question is, who is the father of genetics? What is the difference between heredity and variation? Now, how does a phenotype differ from a genotype? Who are the rediscoverers of Mendel's laws? What is the difference between Mendel's postulates and Mendel's laws? Are Mendel's laws applicable universally? Now, let us first start with who coined the term genetics. The term genetics was coined by William Bateson in 1905. The Greek meaning of the word is genesis or origin. Now, what is genetics? According to Bateson, genetics is the study of heredity and variation. Now, before that, we have to understand what is heredity and what is variation. Now, heredity is the transmission of a character from one generation to the next generation. That is, when a character gets transmitted from parents to the offsprings, we call it as heredity. And then what is variation? The differences which are observed among the offsprings during this process of heredity, these differences are termed as variations. Now, the first question. Who is the father of genetics? Gregor Johann Mendel is known as the father of genetics. Why is he known as the father of genetics? It is all because of his hybridization experiments, which paved the way for the foundation of this special branch of science called as genetics. And the entire world now revolves on this particular science called as genetics. So, father of genetics is Gregor Johann Mendel. Now, let us learn something about Mendel. Now, Mendel was a contemporary to Charles Darwin. We all know Charles Darwin is the most famous scientist for evolution. Charles Darwin is the father of evolution. So, today we learn that father of genetics and father of evolution were contemporaries. Mendel was a teacher by profession. Now, Gregor was the title which he had obtained during his lifetime. Mendel was born on July 22nd, 1822 in Heisendorf. Mendel graduated from Gymnasium in 1840. Mendel worked as monk in Catholic monastery in the city of Brunn. Mendel had wide knowledge on a number of subjects like mathematics, statistics, natural science, pomiculture, that is the culture of fruits, and viticulture, which is the culture of grapes. He studied extensively about the damage which was caused by pea weevil Bruchus PC, and thus he got interested in peace. Mendel conducted hybridization experiments on Pisum sativum, commonly which we call it as garden pea. That was during the time 1856 to 1864. In 1866, he published his findings with the title of Experiments on Plant Hybridization in the Annual Proceedings of the Natural History Society of Bern. Now, was Mendel the first person who had experimented on garden peas? The answer is no. Before Mendel, there were two scientists by the name Knight and Goss who were pioneers in hybridization experiments on edible pea, that is, Pisum sativum. Now, Knight had experimented in 1799, almost more than 5 decades previous to Mendel. His experiments were on garden peas, and the character which he studied was the pigmentation of the flowers. So, he had crossed an unpigmented plant with a pigmented plant in the parental generation. He obtained pigmented plants in the F1 generation. Again, he too served the F1 generation, that is pigmented into pigmented, and he obtained unpigmented and pigmented plants. So this was almost the same as the results which were obtained by Mendel almost 50 years later. Now, when we talk about Goss experiments, which he conducted way back in 1824, almost 2.5 decades previous to Mendel, his experimentations were also on garden peas, and the characters which he selected was the color of the seed. So, he had selected the parental plants, green-seeded variety, and crossed it with yellow-seeded variety. The plants which he obtained in the F1 generation were all yellow-seeded varieties. When he went for selfing of the plants obtained in the F1 generation, he too obtained green-seeded plants and yellow-seeded plants. So, from these experiments, we understand that many years before Mendel had conducted his experiments, similar experiments were conducted by the two scientists, Knight and Goss, and they obtained results which were very much similar to the results obtained by Mendel. Why then Mendel's predecessors failed? The reason for this was mainly because of the lack of numerical treatment of the data. Whenever any experiments are conducted, the results should always be processed mathematically and thereby supported by the statistical significance. Now, this was not done by Knight and Goss. Secondly, they considered many characters at a time. And finally, their main concern was for the improvement of varieties rather than understanding the mechanism of inheritance. Now, let us learn something about Mendel's experiments. For hybridization experiments, the plant should have the following important characteristics. Firstly, there should be more characters to study in the experimental model. The plant should have a short lifespan. There should be a possibility for selfing, and the experimental material should be very easy for hybridization techniques. Now, such a plant having all these characteristics was selected by Mendel, and the experimental model which was selected by Mendel for his hybridization experiments was Pisum sativum, that is the garden pea. This plant had all the important characteristics which led to the successful completion of his work. Now, Mendel's selection of Pisum sativum had important characteristics. Firstly, 7 pair of contrasting characters. Now, the characters which were selected by Mendel, they were easily distinguishable characters. That is, every character can be easily observed with the naked eye. The second characteristic was the plant being an annual plant. That is, more generation can be studied in a short period of time. This was the advantage for an annual plant. Thirdly, the plant had bisexual flowers. The advantage for this characteristic is that pure lines can be easily obtained due to self-fertilization. Now, what were the characteristics of pea plants which Mendel used in his inheritance experiments? He had considered the shape of the seed and the color of the cotyledon. He had considered the color of the flower, the shape of the pod, the color of the pod, and the position of inflorescence and the size of the stem. So, he had considered some characteristics related to seeds, flower, pod, and stems. Now, let us know what are the 7 pairs of contrasting characters which Mendel used in his experiments. The first one was regarding the length of the stem. So, he had taken plants which were having tall stem and plants which were having dwarf stems. So, the character was length of the stem and the alternate trait was tall and dwarf. The second character was regarding the color of the cotyledons. Plants with green cotyledons and plants with yellow cotyledons were selected. The third one was regarding the shape of the seed, round seeds and wrinkled seeds. The fourth one was about the color of the flower, purple colored flowers and plants with white colored flowers. Fifth one was regarding the color of the pod, whether the plant had a green pod or the plant had a yellow pod. The sixth one was the shape of the pod, whether the pod was inflated or the pod was constricted. And finally, it was the position of the flower, whether the flower was axial in position or the flower was terminal in position. So these were the 7 pairs of contrasting characters which Mendel used one character at a time for each and every experiment of his. Now let us learn something about Mendel's experimental methodologies. So basically 3 important methodologies were followed by Mendel. The first one was selection of pure lines. Second one was he carried out his hybridization experiments following the technique of emasculation. And the third one was the crossing techniques which he followed was monohybrid cross, a dihybrid cross and reciprocal cross. Now let us learn about these 3 methodologies in detail. Now, what is a pure line? A pure line is the progeny of a single self-fertilized plant. These progeny exhibit the same character in successive generations. For example, a pure dwarf plant upon selfing will produce only dwarf plants. So, such a parent dwarf plant is termed to be a pure line. During hybridization experiments, the inheritance of a particular character can be studied without any ambiguity if we select a pure line. Next was the emasculation technique. Now, what is this technique? Emasculation technique is the removal of anthers from the plant which is considered as female in a bisexual plant. We know that a bisexual plant is a plant when both the male and female parts of the flower are present in the same plant. That is, androecium and gynoecium both are present in the same flower. Now, According to this technique, what Mendel did was, he removed anthers from a particular flower, from a bisexual flower. And now the part which was remained was only the female part, that is gynoecium. Now this flower or this plant is termed as a female plant. Now he has taken another flower or another plant where the pollen grains were removed from the anthers and they were transferred to this female plant. Now, since pollen grains were used from this plant, now this plant was termed as a male plant. Now, hence, by this process, the pollen grains were transferred from the male plant to a female plant which carried only the gynoecium. Now, this technique is called as emasculation technique, and this was used in all his experiments. Now, let us understand Mendel's crossing techniques. The first technique which he followed was monohybrid cross. Now, what is a monohybrid cross? The cross between two plants differing in a pair of contrasting traits of a single character is called as a monohybrid cross. For example, if we consider the length of the stem as a single character, then the cross between a tall plant and a dwarf plant will be termed as a monohybrid cross. Now let us understand this from Mendel's experiments on monohybrid cross. Mendel has taken a pure tall plant and crossed it with a pure dwarf plant. Now these two plants belong to P generation or parental generation. When a pure tall was crossed with a pure dwarf, all the offsprings were tall in nature. These plants were said to be F generation plants or first filial generation. So Mendel somehow understood that the factor for this dwarf plant was present in these F1 generation plants. Hence, he termed these F1 generation tall plants as hybrid tall plants. Now, Mendel carried forward the experiments by selfing the F1 generation plants. When the first generation tall plants were selfed, Mendel found that the next generation plants were tall and dwarf in the ratio 3:1. So, since a dwarf plant occurred in the F2 generation, so here he understood that this dwarf factor was present in the F1 generation tall plant. So that's why he had considered the tall plant of F1 generation as a hybrid tall. Now he wanted to know whether the tall plants which were obtained in F2 generation were pure tall or hybrid tall, because here he had obtained tall and dwarf in the ratio 3:1. Now to find out whether the tall plants of F2 generation were pure tall or hybrid tall, he conducted the experiments for the third generation by selfing all the plants of the F2 generation. So, in this cross, we find that the tall plants and dwarf plants were in the ratio of 3:1, F2 generation plants. Now, when the dwarf plant of F2 generation were selfed, all the plants obtained in the F3 generation were dwarf. Now, he wanted to know whether the tall plants of F2 generation were pure tall or hybrid tall. Hence, every tall plant of the F2 generation was selfed. So, when this tall plant was selfed, he found that 1/3 of the tall plants of F2 generation produced all tall plants, 100% were tall. Hence, he labeled this tall plant as a pure tall plant. And then he noticed that 2/3 of the tall plants of F2 generation produced tall and dwarf plants in the ratio 3:1. In the ratio 3:1 in the F3 generation. So 3 plants were tall and 1 plant was dwarf. So 2/3 of the tall plants showed this result. So he termed these 2/3 of the tall plants as hybrid tall. So the pure tall produced all tall plants, pure tall plants in the F3 generation, whereas the hybrid tall plants produced tall and dwarf plants in the ratio 3:1. Therefore, the F3 generation proved that 1/3 of the tall plants of F2 generation were pure tall, whereas 2/3 of the tall plants of F2 generation were hybrid tall, and 1/4 of the total plants of F2 generation were pure dwarf. Thus, by selfing the F1 plants, when dwarf plants were obtained in the F2 generation, Mendel concluded that the F1 generation tall plants were hybrid. Similarly, by selfing the F2 generation tall plants, he found out that 1/3 of the tall plants were pure tall and 2/3 of the tall plants were hybrid tall. So, by conducting the experiments till F3 generation, Mendel was able to distinguish between a pure tall and a hybrid tall. In this way, Mendel continued his experiments with all the 7 pairs of contrasting characters, taking each character at a time, and observed that there is a dominant and recessive relationship between these traits of a single character. So from all the experiments which he had concluded, he came to a conclusion that the 7 pairs of contrasting characters had 2 alternate traits, a dominant trait and a recessive trait. For example, the length of the stem had a dominant trait which was tall, and the dwarf was the recessive trait. Considering the shape of the seed, round shape was dominant over the wrinkled shape. Now, yellow seed coat color was dominant over the green seed coat color. Now, when we consider the 4th character, that is the color of the flower, purple color was dominant over the white flower color. Now, considering the position of the flower, axial flower was dominant over the terminal flower. Shape of the pod, inflated pod was a dominant trait and constricted pod was a recessive trait. And regarding the color of the pod, green pod is dominant, whereas yellow pod is recessive. So from all the experiments which he had conducted, finally he concluded that each of the 7 pairs of contrasting characters had 2 alternate traits, a dominant trait and a recessive trait. The next crossing technique was a dihybrid cross. Now, what is a dihybrid cross? It is a cross between 2 plants which differ in 2 pairs of contrasting traits of 2 different characters. For example, let us take 2 different characters. The first character is shape of the seed and the second character is color of the seed. So, if we cross a plant with a round seed having a yellow color seed with another plant having a wrinkled seed which is green in color, such a cross is called as a dihybrid cross, because here we are considering two characters at a time. So let us see the dihybrid cross which was conducted by Mendel. Now Mendel has taken a round seed with yellow seed color and crossed it with a wrinkled seed with a green color. Now these were termed as P generation plants. Now when these plants were crossed, he obtained round and yellow seeds in the F1 generation. Here he understood that the factors for the recessive characters were somewhere hidden in these plants. So what he did was, he selfed the plants, F1 plants, to find out the result of the F2 generation plants. And here he found out that a new variety, which he called it as a recombinant variety, they appeared in the ratio of, the recombinants were in the ratio of 3 and 3. And this 9 and 1 are the parental combinations. So 4 different types were obtained in the F2 generation. Round yellow, which is same as the parental combination. Wrinkled green, again same as the parental combination. And 2 new combinations were obtained, that is round green and wrinkled yellow. So these 2 are termed as recombinant varieties. Now the ratio were 9:3:3:1. Now this we call it as a phenotypic ratio. When we look into the genotype, the genotypic ratio of the F2 generation was 1:2:2:4:1:2:1:2:1. So this was the genotypic ratio which was obtained in the F2 generation. Now Mendel wanted to test his results over some of the doubts he had. Now Mendel tested the results with a reciprocal cross. Now what is a reciprocal cross? In a reciprocal cross, the characters involved in the cross remain the same, only the sexes are reversed. Now this reciprocal cross was conducted because Mendel wanted to know whether there is any relationship between the characters observed in the next generation and the sex of the plant. The results of such reciprocal cross were similar to the crosses which he had conducted in his monohybrid and dihybrid cross. So let me show you what a reciprocal cross is. Suppose in the first cross, a tall plant is taken which is crossed with a dwarf plant. The tall plant is a male plant here, whereas the dwarf plant is a female plant. In this, the result of such a cross is a tall plant. Now the reciprocal to this cross is the sexes are reversed in this case. Here, when the tall plant taken was a male plant, in a reciprocal cross, the tall plant taken is a female plant. And the dwarf plant in the first cross was a female plant, whereas the dwarf plant in the second case is a male plant. So in the reciprocal cross, only the sexes of the parental generation were changed. But here we find that the results are all the same. The next generation plants were all tall. So from these reciprocal crosses, Mendel concluded that there was no relationship between the characters and the sex of the organism. Now, from all the experiments which were conducted by Mendel, he came forward with some deductions. So, Mendel has put forward 4 principles. The first principle was about unit factors. So, these days, these unit factors which were termed by Mendel, now we call them as genes. The second was about the principle of dominance. We have seen that when Mendel has conducted a monohybrid cross, taking each character at a time, every character had two alternative traits. A dominant trait, which was found to be having a relationship with the other trait, which is a recessive trait. So a dominant and recessive relationship was always found between a pair of contrasting characters. This is called as principle of dominance. The third one is principle of segregation, and the fourth one is principle of independent assortment. The first three principles were based on monohybrid cross, whereas the last principle is based on a dihybrid cross. Now the third and the fourth principle we will be studying in detail in the coming videos. Now, what was the reason for Mendel's success? The first reason was Mendel studied one character at a time, and that is the reason why he was successful. Moreover, Mendel underwent statistical analysis of the qualitative and quantitative data of all the experiments which he had conducted, which I have explained previously. Next, Mendel used pure lines in his experiments. That was where he didn't come across any ambiguity. Mendel carried out his experiments till the second and third generations. This was basically to determine whether the plants which he obtained in the F1 generation and F2 generation were pure plants, that is pure tall, or hybrid tall. So this was the most important reason for his success. Complete dominance of selected traits. The 7 pairs of contrasting characters which Mendel had selected, they were completely dominant over their corresponding recessive traits. This was another reason for his success. And as I have explained earlier, Mendel tested the results with reciprocal crosses to find out whether the characters were linked to the sexes of the organism. Moreover, presence of characters of the pea plant on different chromosomes. This was another most important reason. All the 7 pairs of characters which Mendel had selected were not linked in any case. They were present on different chromosomes, and hence these were the reasons for Mendel's success. In spite of having so many reasons for Mendel's success, what were the reasons for obscurity of Mendel's findings? This was because the entire world was preoccupied with Darwin's theory of origin of species, which appeared in the same time, 1859, the same time when Mendel was busy with his experiments. The second reason was obscurity of the journal in which Mendel's findings were published. Had Mendel's findings were published in some other international acclaimed journal, his works would have been accepted worldwide. Moreover, 2 scientists, Nageli and Kramer, advised Mendel that he should perform the experiments on some other plants and get the similar results to prove his findings, and suggested to perform the experiments on a hawkweed, Heretium. Mendel followed the advice and conducted experiments for 4 years, but the results were completely different, and that was where Mendel was disheartened, and finally he left the world. Now later it was known that the material which was suggested by Nagel and Kramer, that is the hawkweed, is a parthenogenetically reproducing plants. Therefore, the results can never be similar to those results which are obtained from a bisexually reproducing plants. So these were the reasons for obscurity of Mendel's findings. In 1900, 3 different scientists from 3 different parts of the world, Hugo de Vries from Holland, Karl Correns from Germany, and von Schmark from Austria. They performed experiments with different experimental material and they came out with the results which were very similar to the results which were published by Mendel. These three great scientists wanted to give full credit to Johann Mendel, who had published similar results almost 50 decades earlier, and therefore Duris, Correns, and Schirmack were thereafter known as rediscoverers of Mendel's laws. They formulated Mendel's 4 principles into 2 laws. First law of Mendel, known as law of segregation, and the second law of Mendel, known as law of independent assortment. We are going to learn about these laws in the upcoming videos. Now, from the video which you have heard till now, can I test your knowledge? Here are some of the questions related to our video lesson. If you cannot answer, just go back to the video and come again with the answers. Pause here and answer these following 7 questions. Here are the answers for the 7 questions. The references which I have used for preparing this video lesson are given here. I am greatly inspired by the LMS initiative of Commissionerate of College Education and Bharat Padhe Online initiative of Government of India. The Google images which I have used in this video lesson are labeled for reuse. Thank you.